Okay, let's look at techniques on these, since it's probably going to take me about the amount of time we got left to go through this, because it'll probably take me a little bit of a minute. On the first one, we talked a little bit already, but I'm going to go through it because we need to. Anytime you see the infinity as x approaches, you should be thinking dividing by the highest power of x. Usually it's involving a fraction, and so on. Because we're using the fact that 1 divided by infinity goes to 0. And when I divide by the highest power of x, a lot of things are going to go away. A lot of things are going to be in there in 0. Most of you probably remember the shortcut. If you just find the highest power, the 3 will end up staying, and the negative 6 will end up staying. End up with negative 1/2. We just talked this guy, but I'll talk through again. I see the little one-sided thing. I'm jumping in my head. I'm thinking I might have to test for positive or negative infinity if I can't make it go away. Because when I plug in the negative 3, boom, blows up. Can't do any of my factoring things, any techniques to get rid of it. So this is going to go to infinity. I just got to decide positive or negative. And I'm going to pick a number a little bit bigger because of the positive. So I'm going to do negative 2.9 and see what I get. Negative number or positive number. This guy down here has a negative 2 with a one-sided thing. So I'm thinking the same technique. But then when I look at the problem, what jumps out at you right here? There's a lot of stuff I can factor here, isn't there? And I don't even know if it even blows up, but I'd probably factor it and see if some of the stuff goes away on this one. I got a difference of squares and the common x squared minus 6x, or x squared minus x minus 6. This one up here, when you see it, it's got trig in it, and the big thing with trig, x always has to go to what so we can use our 3 things? Why, when the sine of x over x equals 1, tangent of x over x equals 1, what is the limit approaching? Or does it work all the time? I confused you all.
0.
Has to go to 0. If it's going to pi or pi over 2, it doesn't work. Those 3 things we have on our blue sheet only work when x is going to 0. This guy here is Carly's favorite. We all probably know the answer, right? 5 over 2. But you've got to show me the money on how you get there. Divide by x, top and bottom, multiply 5 and 5 and 2 and 2.
Whoa. Okay.
Right now we're going, what we need to do, you can check your notes. This one here, when I look at it, what jumps out at you? That square root. First, just check to see that it blows up. It does, and so the technique for this guy would be most likely rationalization because of the square root. That means multiply top and bottom by the plus 3. This guy down here, it's got the plus. It looks like it's a one-sided thing, but when I look at this, it looks like the bottom factors, and it looks like the top is going to be a god-awful cubic thing, huh? We might try a grouping. But I think if you try step 1, you'll find things are a lot nicer than that. On to the next.
Yeah. So number 5. How is that? Okay. I don't know if I did it.
Next one on the list has got another infinity one. But what's the additional trick you got to watch out for on this one? Got that square root. What happens? What are you supposed to do with the square root? Nah, it's still an infinite
Because
limit.
that's not in the brackets.
What's the highest power on this one? X. And when I divide it, I'm great, but that square root is an issue. At the end, after I get my answer, in this case negative 1 over the square root of 7, make sure and go back and check, is it going to a negative 1 over the square root of 7, or is it going to a positive 1 over the square root of 7? That's the additional thing you're going to see with that. Yep.
How do you know that again? That might have been a really
If I
good
pick-
question, but
We know the square root of any number is always positive, so the bottom is always positive. But on the top, as I pick a really, really large number and try and subtract it from 4, that'll be a negative number on the top. Here's the piecewise stuff. What do I always do for pieces? Plug those numbers in and see what happens, right? In this case, it's a limit question. If they're the same number, that's the answer. If they are different, it does not exist. Now things are going to get a little more challenging as you work your way down here. These last 4 are doozies. That first one up there. X cosecant of 6x. What are you thinking? Besides, oh crap. Because I need a sine of x over x, right? Cosecant and sine are reciprocals of each other. Good idea. How about this one? Negative 2. I plug it in. Oh boy. What do we got on the top? It's not a cubic even, it's something even worse than that. But what do I get to do? There's one thing. If I can try and group it, it probably won't help. How am I going to factor it? In a way, this is kind of a do the math, polynomial division. Actually do the division. Divide the thing by x plus 2 using the chart. Synthetic chart, put the negative 2 in the upper left-hand corner. Zip your way through, see what you get, see if it actually cancels out. This one stinks. Not much better than this one either. But this one up here. Does 1 blow it up? Probably factor the bottom. Most likely you're going to have to factor the top. We just kind of did one earlier today with that, didn't we? A little grouping, most likely first and third, second and fourth. You'll probably get one of those to cancel out. That's my guess. Last one on the list. Oh boy. Any thoughts? No prayers. It's cool. Break it up into 2 fractions, outstanding, because there's one thing on the bottom and a plus on the top. So I can break it into that fraction plus that fraction. And both of those should work out nicely. Have fun with those.
Don't say like that.
Yes, sir.